I noticed something odd. I had this dish of water, and if I sprinkled yellow sand grains on the water, some of the sand grains sank, which I would expect since solids are supposed to sink in liquids. But most of the sand grains floated. I did not understand. Then I added a bit of detergent in the water. It had a purplish color. And now when I sprinkled sand grains on the detergent water, most of the sand grains sank. First, we have to recognize that water is an extremely unusual liquid because of two types of bond that it forms. The polar covalent bonds create partially positive and negative poles on water molecules. The hydrogens are partially positive, the oxygens are partially negative. As a result, there is an attraction between the opposite poles on different molecules. This attraction, known as a hydrogen bond, then means that water molecules come closer together. They pack in more tightly because of the attraction that the positive and negative poles on different molecules feel for each other. This is why things float on water where they would sink in a different liquid. So dust, sand, insects can float on water as a result. Water has a surface tension because of the attraction that these water molecules feel for each other. But this is a problem in the respiratory system, because our air sacs, our alveoli, they need to be kept moist or else the cells would dry out and die. But if they were lined by simply water, the surface tension of the water would collapse the alveolus. Tragically, this does cause deaths in infants every year, especially at risk are premature infants. As a result, we have a type of cell known as a type 2 cell, here depicted in green, that adds other molecules to the fluid in the alveolus. So in addition to water, there can be proteins. So like this detergent in this simulation, it is not pure water, and there are then fewer attractions, fewer hydrogen bonds between partially positive and partially negative regions of the molecules. There is less surface tension, and this helps our alveoli stay open rather than collapsing, thanks to the surfactant added by the type 2 cells, which reduces the surface tension of water.